All right, what's going on, everybody? Today we're going to be doing another LeetCode problem. This one is called min stack. By the way, face reveal. Let's get it. Yeah, okay. I really want to delete this take, but I'm just going to muster up the courage to continue here. So, they want us to design a stack that supports push, pop, top, and retrieving the minimum element in constant time. So basically, they want us to implement the min stack class, meaning we have a stack, but not only can we return the top element in constant time, but we can return the element with the minimum value in constant time, wherever that element may be. Again, we have to have this min stack constructor, which initializes the stack object. They want us to implement the push method, which takes an argument val and pushes that element val onto the stack. They also want us to implement pop, which removes the top element of the stack. Top just returns the top element of the stack, returns that value there, and then get min returns the minimum element within the stack. And all of these functions need to be O of 1 time complexity, meaning constant time. So we're obviously not allowed to search through our stack when we're or when we're saying get min to find the minimum value. That's linear, we can't do that. So one of the first things I thought when I saw this problem, I was like, okay, well, why don't we just have a single integer value and just keep track of the lowest element there? Why not? Well, the problem with that is if you were to pop that element, how do you know there's no way to know which is gonna be the new minimum element. Think about it. So if your new minimum element is somewhere in the middle of the stack and you pop the minimum value, you're going to lose track of what the minimum is. So the trick to this problem is you're going to want to have if you were to implement this problem with stacks, you're going to want to have two stacks, where one stack has the actual elements and values and everything like normal, and then the other stack keeps track of the current minimum each time you insert a new value into the stack. That way, for each element, you always know what the minimum element is when you inserted that element. So that's the trick. You can use different data structures under the hood to, and there's different data structures that are acceptable. I would recommend first asking your interviewer, if you get this question, just straight up, what data structure would you prefer me use here? For this video, I'm just going to use STL vector. So let's go ahead and get into the code. So using STL vector, which is just like an array with some built-in methods that makes space allocation, reallocation easier. We're going to have a vector of integers, and if you were making a really generic C++ class, usually you'd use a template, so you could use any data type here, but they just want us to use integers, so that's what we're doing. So we're gonna have a vector of integers, and I'll call this one my stack. That'll just be the function as your traditional stack. It'll just store all the values in it. You'll be able to access the top value and so forth. Now we're gonna have to mirror my stack and store the min values at the corresponding position. So min stack is always going to have the same number of elements as my stack. And I'll show how those get updated in the push function. Now, so the constructor, this can just be empty. These private data members will automatically be initialized upon calling this. This is just a feature of C++. So nevertheless, for a push function, we're going to, the first thing we could do is just insert that value into my stack like usual. So you can use the push back method to add an element to the end of a vector in C++. So we're going to push back val. Now we also need to insert the this value into min stack if it's the new minimum value. Otherwise, we just keep the value in min stack as is. Also, if min stack is empty, we shouldn't be looking inside of min stack to see what the minimum value is. So we need to see if min stack is empty first. So, and you'll see what I mean when I finish off this function. So if min stack is empty, then we can basically just push back that minimum value to, or we can just push back the value that we got as an argument into min stack, because there's nothing in here. So this is going to automatically be the minimum value, and we're going to push it there. You know, otherwise, if min stack has elements, and I'm noticing I did that, we don't want those. So if min stack is populated, then basically value is either going to be the minimum of, it's either going to be value or it's going to be the current minimum in the stack, which is just going to be at the top of min stack. So that's going to be value, and then we can just insert that into the stack with the pushback method. So pushback val. So that's basically going to keep track of our minimum value for every element in our in my stack. So this is pretty much the key to this problem. That is, so for the pop method, we're basically going to be, since we're using a vector here under the hood, we want to just remove the last element of the vector. And to do that in C++, first of all, we need to make sure our vectors are not empty, so we're not doing anything illegal. So myStack.empty and minStack.empty, just to ensure that both of those are empty. And if they both are, then we can use the pop back method to erase the last element of those vectors. And remember, since they're symmetric and the items that are being stored, they have this, and they not really symmetric, but they have the same number. We need to pop from both of them. So, and then empty, and this is completely wrong code here. This needs to be return. You know, obviously if they're empty, then we return. If they do have elements, then we can pop. So that's what I meant to do there. Okay, and then for the pop, or the top method, sorry, this is going to be very similar code here. So we can first check if my stack is empty. And, you know, they just want us to return the top element of the stack like normal. So notice that it does want us to return an integer. So if we don't find it, I'll just return -1. It doesn't specify anything, you know, about what to do there, but to avoid running into any issues there, we'll just return -1 if it is empty. And then if not, we can return the top element. And to get the top element, you just do .back. I believe we already used that up here somewhere. Yes, min stack.back. So that basically just accesses that last element in the vector to kind of act as, to mimic the stack's functionality of returning the last element. And I think in STL, the stack is, the stack data structure is pretty much the same implementation as vector under the hood. They pretty much just, it's got different naming notation, so it's easier for the reader, but nevertheless, for get min, we can do the same thing, but remember we have this other stack that's always storing the minimum element at the end, so the code here is really straightforward for this part now. We just return that last element of the min stack, you know, given that the min stack is not empty. So that's it for the code for the min stack class. Let's just look through this to see if there's any bugs. And empty, back. I don't see any, but you know, sometimes I make bugs. Everyone makes bugs sometimes. Okay, here we go. So the initial test cases were accepted, so let's just submit this to see our percentages. But beats 90% for runtime and then 81% for memory. So this is should be an acceptable approach. Again, before you get into this problem in an interview, I would ask the interviewer, what data structure they'd prefer you to use under the hood before you start doing a bunch of stuff with a data structure they might not be looking for. So I would just double check that, and then, but yeah, this is pretty much the solution here. And all of these methods are, once again, constant time. So hopefully this video helped you understand this problem and one possible solution of the problem. If it did help you, please leave a like and subscribe. And I'll see you guys in the next. So thank you and peace.